What will happen to a person in outer space without a spacesuit? And how long will they remain alive? Nobody doubts that eventually they will die. But from what exactly? Will they be torn apart, suffocate, have their blood boil, or burn up in the sun? So imagine you're in outer space, where it's extremely cold. -271 degrees Celsius or -455 degrees Fahrenheit. Of course, practically all bodies turn into ice at such a temperature. But how does this happen? We know that the higher the temperature of a body, the faster the molecules move within it. The fast-moving molecules of a hot body collide with the molecules of a cold body, losing their speed in the process, thus causing the body to cool down. However, space has a very low density. For instance, at an altitude of 400 kilometers, it's less than 1/quadrillionth of a gram per cubic centimeter. So there's simply no one to transfer your heat to. Therefore, a person won't freeze immediately but will only feel a slight chill. It may take several minutes before complete freezing sets in, so this is not the main cause of death in outer space. Let's consider a completely different effect. From the sun one can receive very intense radiation burns or overheat. Indeed, there is a lot of radiation there which on Earth is retained by the atmosphere. However, in space, there is no such protective barrier, so you can get burns on exposed parts of the body in just 10 seconds. But a spacesuit or clothing can only protect from this for a short while. And as for overheating, even if you were to absorb all solar radiation, then it would take at least 24 minutes to reach the lethal temperature for the body of 43 degrees Celsius or 110 degrees Fahrenheit. Not again, it won't kill you. The next deadly candidate is pressure. In space, the pressure is very low, practically zero due to the absence of atmosphere. Inside a human, however, the pressure is maintained at 1 atmosphere, which can cause the person to burst due to the pressure difference. But is this pressure difference really that significant? Not at all. Our tissues are strong enough to withstand such stress. A person may expand, but not burst. However, this expansion will lead to compression of blood vessels, and within just 90 seconds, blood flow can stop, leading to oxygen starvation and eventual death. But what else can kill a person even earlier? Can a human's blood boil? Indeed, when pressure decreases, the boiling point of any liquid decreases. But even if there is zero pressure outside, there will still be pressure inside the blood vessels of the human body. We're talking about the pressure measured with a blood pressure monitor. At a pressure of 75 millimeters of mercury column, blood would boil at 46 degrees Celsius or 115 degrees Fahrenheit. But since blood has a body temperature of 36 and 6 degrees Celsius or 97 degrees Fahrenheit, it would not be hot enough to boil quickly. Boiling blood in outer space can lead to serious consequences, such as gas bubble formation in the circulatory system, circulation problems, and loss of consciousness. However, before the blood starts boiling, the person would likely already face other deadly dangers. For example, such as decompression sickness. All liquids have this property. They can dissolve gases. Blood can also dissolve nitrogen and oxygen, which we breathe in. With a sudden decrease in pressure, the following effect is possible. This dissolved gas is released back in the form of bubbles that can block blood vessels and lead to tragic consequences. Divers are most at risk from this danger. At a depth of 40 meters, the pressure is 5 times greater than atmospheric pressure. Such an effect is possible with rapid ascent. This is called decompression sickness. But when you are in space, we deal with a pressure drop from 1 to 0 atmospheres. At these parameters, the diameter of the bubbles formed is less than 8 micrometers, and the diameter of the smallest blood vessels is from 8 to 12 micrometers. It turns out that this effect is absolutely safe and does not lead to any serious consequences. So, we've reached the reason that can really take you out fast. It's oxygen depletion, but how quickly does that happen? If I'm not burning up, freezing, or boiling my blood, can't I just hold my breath? No, the pressure in the lungs is high enough, and the force with which air will rush out is significant. There's no stopping that. As a result of a very large exhale, a person will lose all their oxygen supply, leaving them with about 10 seconds before they lose consciousness. During this time they can take a couple of rational actions aimed at rescue. Well, for example, dial 911. Now, if you see in any movie that people are moving through space without a spacesuit, you'll know that it's not such a far-fetched idea. After all, it turns out that the human body is so resilient that it can withstand even such extreme conditions for some time. And that's all. Thank you for watching. Give it a thumbs up if you enjoyed the video. And subscribe to my channel because the next video will surprise you just as much. See you in the new videos.
Hobblocks.